In this video, we're going to take a look at solving and graphing linear inequalities with two variables. So this means we're going to be graphing on a coordinate grid. If you haven't watched the previous video on solving and graphing inequalities in one variable, I suggest you take a look at that first before you jump into two variables. So let's take a look. We're going to go ahead and remember that solutions to inequalities, there are infinitely many of them. So when we go ahead and graph on a number line, we used an arrow and circle to indicate our true statements or our solutions. When we're graphing on a coordinate grid, we're going to need to show all of the ordered pairs that are possible solutions. And we're going to do that by graphing and shading. So let's take a look. First thing we want to know is if we have a solution. So this is kind of like testing out your inequality. So we're going to go ahead and test out here. We have an inequality statement. X minus 3y is less than 6. What is a solution to the inequality? A solution is a value that makes the inequality true. So we're going to go ahead and test out each one of these inequalities, of these possible solutions, into our original statement. So this is just plugging in and simplifying. So for our first ordered pair 0, 0, we're going to go ahead and plug that into the first, or to our solution. I'm sorry, to our inequality. So we have 0 minus 3, plug in 0, should be less than 6. So let's see if that's true. 0, negative 3 times 0 is 0. Is that less than 6? So let's see. Is 0 less than 6? Is that a true statement? That's what you have to think of. And I often tell students to go ahead and read it out loud because you might catch yourself saying something out loud that is false or funny versus just reading it. So is 0 less than 6? Yes, that's true. So 0, 0 is a possible solution. Let's try the next one. Let's plug in 6 and negative 1. So we plug in 6 for x. We plug in negative 1 for y and simplify. Make sure you follow the order of operations. We have to do negative 3 times negative 1 first, which is 3. So we have 6 plus 3 should be less than 6. So let's see, 6 plus 3 is 9. Is 9 less than 6? No, that's false. So that's that funny solution that I'm talking about. When you read it out loud, you'll catch yourself saying something silly. Let's try the next one. Plug in 10 for x and 2 for y. So we have 10. Negative 3 times 2 is negative 6. Is 10 minus 6, let's see, that's 4. Is 4 less than 6? Is 4 less than 6? Yes. That is a true statement. So that means that 10, 2 is going to be a possible solution. We'll also try that last one, negative 1, 2. I'm going to do the work up here again. So I've got negative 1 for x, 3, and plug in 2 for y. I somehow wrote that very weird, so let me fix that. We've got, again, negative 1 minus 3 times 2. There we go. So we've got negative 1, and negative 3 times 2 is a negative 6. That should be less than 6. Negative 1 minus 6 is negative 7. Is that less than 6? Yes. So that gets us a true statement as well, meaning negative 1, 2 is a possible solution. All right, when we graph inequalities with two variables like x and y, we have to graph using a boundary line. This is like when we chose either to open or close our circle when we were graphing on a regular number line. But here we're graphing on a coordinate grid. So when we have the less than or equal to and greater than or equal to symbols, we're going to draw our line, just like when we were graphing lines, we're going to draw that line solid. If it's just a less than or a greater than symbol, we're going to use a dashed line to draw our line. And then we pick a test point. This is what we just practiced. We pick a point in space that's not on either line, and we plug it into our two equations or our equation, and we decide if it's a solution. If it is a solution, then we shade. We're going to go ahead and color in our graph. We're going to shade that region if it is true. If it's not true, then we just shade the opposite line or the opposite side of the line. So let's see if we can practice that. Here we go. We've got y is greater than 4x minus 3. Think of this just like an equation. You want to first find the y-intercept. Our y-intercept is at -3, so I'm going to go ahead and dot that on my graph. So remember, y equals mx plus b. Graph your y-intercept first. Down here at -3, I'm going to put a dot there. And then I'm going to use my slope, and my slope here is 4, or 4 over 1, to rise and run and put my next dot, just like regular graphing of a line. So I'm going to go up 4, 1, 2, 3, 4, and over 1. Up 4, 1, 2, 3, 4, and over 1. Now normally, once I have a couple of dots, I would go ahead and take my pencil and draw a line right through them. But because we're talking about inequalities, I want to look at my symbol. This is a greater than symbol. If I was graphing on a number line, I'd use an open circle. So if we are graphing on a coordinate grid, we're going to use a dashed line, which means all the points on this dashed line are not included. We're going right up to the dashed line, and that is a poorly drawn dashed line, but you get the picture. Let me zoom out a little bit. There you go. So that's our dashed line. You can even draw a full line and then erase. But next we're going to go ahead and pick a test point. That's part 2. We graphed it. We did our boundary line correct. We dashed it. And now we're going to pick a test point. So this is where I pick a point out in space. Any point, any ordered pair I want that's in space, but cannot be on the line. Can't be on the line. If it's on the line, that's not going to tell us which direction to shade. We want to pick a point, and it's either going to be true or false. If it's false, we don't shade that side with the point. We shade the other. If it's true, that's the side we're going to shade. I would encourage you to pick 0, 0 when at all possible, and that kind of eliminates any mistakes we might make. Helps to eliminate any mistakes. So I'm going to go ahead and pick 0, 0 as my test point. It's right in there. I don't know yet if it's a solution until I plug it into my original inequality. So I have 0. 0, 0 is my test point. And I'm going to go ahead and plug it into my equation, my inequality I should say, and see if it gives me a true statement. 4 times 0 is 0. So let's see, is 0 greater than -3? Is 0 greater than -3? Yes, it is. That is a true statement. If it's a true statement, then I'm going to take my pencil, my highlighter, and shade that side of my inequality. And it doesn't have to be perfect. You don't have to fill in every little speck. You're just shading in that side where the test point was true. Okay, so that's where we're shading the true side. If for some reason when I tested out my point that I picked at random, if it was false, then I would not shade that side. I would shade the other side. This shading is showing us all the possible solutions to this inequality. So any ordered pair here in orange would be a solution to this inequality. It would work in that inequality statement. Let's go ahead and try another. Graph this. Well, before we can graph it, we've got to solve it. So let's remember how to solve. I'm going to go ahead and subtract 2x on both sides. I'm going to get -y is greater than or equal to -2x plus 8. I've got some more steps. I've got to divide by -1 everywhere. Remember that when you're dividing by -1, you reverse the symbol. So I'm going to get y less than or equal to 2x minus 8. My symbols all change. This is what I will go ahead and graph. My y-intercept is at -2. Now, it doesn't look like I have, I'm sorry, my y-intercept is at -8. It doesn't look like I have 8 spaces on here, so I'm going to count by 2's in both directions. So this is going to be -2, -4, -6, -8. So here's my y-intercept. I'm also going to go ahead and count by 2's on my x-axis as well. So here's my y-intercept, and my slope is 2 over 1. So I'm going to go up 2 and over 1, up 2 and over 1, up 2 and over 1, and so on and so forth. I'm getting lots of dots here. This is great. That's going to give me a lot of points. And I'm going to go ahead and look at my symbol. It's less than or equal to, so I get to draw that solid line through all of my points. Now my job is to pick a test point, and I need to pick a point anywhere in space. And my origin is definitely out in space here. It's not close to the line at all, so I'm going to use 0, 0 as my test point. If you don't like 0, 0, pick another point. Pick 1, 1, -1, -1, whatever it is out in space that's not on the line, you pick. And we are going to go ahead and test it out into our original inequality, because we may have made a mistake here in the graphing. I don't know. So we're going to say 2, 0 minus 0 should be greater than or equal to 8. 2 times 0 is 0, minus 0 should be greater than or equal to 8. Is 0 greater than or equal to 8? No, that's false. That's okay. Here's my test point. It was 0, 0. When I plugged 0, 0 in, it gave me a false statement. So all that indicates is, you know what? You're not going to shade that side. That side does not have a solution. So just say shade the other side of your graph. So we're going to shade over here. And you don't have to fill in every speck of white. You don't even have to get like super close to the line. Just shade one side or the other. In fact, I don't really want you to cover up your line either, because then depending on if it was solid or dashed, that might not be visible once you color over it. Let's take a look at this next one. It says y is greater than -3. All right, so if we remembered graphing, y is greater than or equal to -3. On our number line, we go to -3, put a dot, and then we're going to cross that. So I'm going to go ahead and use a solid line here because of that greater than or equal to symbol. Now, where are the values greater than or equal to -3? Well, all the values that are greater than or equal to -3, think of your y-axis as a number line. Here's -3, there's -2, -1, 0. Where are all the numbers that are greater than -3? They're above the line. Super. Shade it. Shade above. X is less than -1. All right, on the x-axis, I go to -1 and I put a dot. When I graph this, I'm crossing the x-axis. And this time, because of my symbol, it's going to be a dashed line. So I'm going to just dash it here. And I want to use that x-axis to help me with my shading. So this is -1, here's 0, 1, 2, 3, 4, this is -2, -3, -4, and so on and so forth. Where are all the numbers that are less than -1? The numbers less than -1 are to the left. So I'm going to go ahead and shade all the values that are to the left. Oops, I got a little crazy there and crossed my dot there, but anywhere over here. Remember that if you have less than or equal to, you're shading below the line. If you have y is greater than or greater than equal to, you're shading above. For vertical lines, if x is less than -1, you shade to the left using less than